Hello everyone, today we will continue with the same problems, okay? That is a problem based on the local maxima and minima. See this question, prove that the radius of the right circular cylinder of greatest curved surface area which can be inscribed, which is placed inside the given cone, and you have to prove that it is half of that of the cone. There is a one cone, you have to place a cylinder, then you have to prove that radius of the cylinder is half of the radius of a cone. Let us consider our diagram so that you can understand it. Let me consider this is a cone, okay? There is a one cone is given. This is a cone. Now I will consider this point as O, okay? Now this is the radius of a cone. We will consider this point as A, and we will consider the radius of a cone OA is equal to R. So clear? Now this is the height of a cone that we will consider. So this will consider as a H. So this is A, this will be B, and this is C. Then height of the cone, that is OH, is equal to B. Is it clear? We have considered one cone and radius OA is equal to R, and height of the cone is OB will be equal to H. Now you have to place one cylinder here. Is it clear? Please place one cylinder here. Now this is a one cylinder placed here. Is it clear? Now this is a cylinder. Understood? So this is a one cone is there, and the radius we have considered and the height of the cone is considered. Now we have placed one right cylinder. Is it clear? That means we have considered one cone. Now we have placed a cylinder. We will consider this as E, F, G and H. Okay? And we will consider the radius of a cylinder as X. Is it clear? Let radius of the cylinder, that is, now the length OH is equal to X. Okay. Now you have to prove that. What do you have to prove? Radius of the cylinder is half of the radius of a cone. Here we have considered radius of a cone as R, radius of a cylinder as X. We have to prove that this is half of that, means X should be equal to R by 2. We have to prove that. And one more thing is given here. See, circular cylinder of a greatest curved surface area. That will be the maximum value. That also we have to prove. First, let us consider. Let S be the curved surface area of a cylinder. Okay, surface area of a cylinder. Now, see, we have considered S is the surface area, curved surface area of a cylinder. What is the formula is given? S is equal to 2 pi RH. Remember this, 2 pi RH. Here R is the radius of a cylinder and H will be the height of a cylinder. Already we have considered the radius of a cylinder as X. Now we need to find the height of a cylinder. See here, this will be the height of a cylinder. That is FH will be the height of a cylinder. Now we need to find the value of Fh. Here you have to observe this one. Here two triangles. This triangle. See, this triangle and this triangle are the two similar triangles. Agree? See, this angle is common for both the triangles. See this one. So this angle is common and this will be 90 degree. Obviously, if it is these two angles are same, then because total angle will be 180 degree. So this is also a same, right? So these two triangles are similar triangles. Which one? A, H, F. Here A, H, F, and another one is A, O, B. A, O, B are similar triangles. Is it clear? These are similar triangles. Now, by using this one, we can write H, their ratio should be same, right? So that means HF by using this HF divided by length of this height of this OB, HF by OB should be equal to, is it clear? HF by OB should be equal to, here this value, radius of this one. Okay, so this side now we have considered HF divided by OB should be equal to, we'll consider this side, the side of this one will be HA, that should be equal to AH divided by this side will be OA. Is it clear? OA. I hope you understood this. See, this is a one triangle, okay? This is a one triangle and this is another triangle, bigger. Now first we have considered this height. HF divided by OB should be equal to this length ratio, that is AH divided by OA. Now we will substitute this one HF. What is the length HF? We need to find. So we will write as it is, that is HF divided by OB. OB is the height of a cylinder, right? So we have considered as H is equal to AH. AH is, I can write, see this one, AH value can be written as OA minus OH. Clear? AH can be written as OA minus OH. OA minus OH. What is OA? OA will be the radius of a cone that we have considered as R, minus OH. This is the radius of a cylinder we have considered as X. Is it clear? So by this I can write AH has R minus X. So this will be equal to R minus X divided by OA. What is OA? OA. So this is also a radius of a cone. We have considered OA is equal to R. So we write OA as R. Now by this we can write the height HF is equal to H into R minus X divided by R. Now just we'll substitute this value in this one, then we'll simplify. Just I have substituted the values. 2 pi radius of a cylinder is considered as X. So we have substituted R is equal to X and the value of H, height of a cylinder, we got it as H into R minus X divided by R, right? So it is of the form S of X, so we'll differentiate. Before differentiating this one, we'll take the constant out. So I can write S of X, the term without X will take out, that is 2 pi H divided by R, will multiply with this X. So this will be X into R minus X into X will be X squared, right? So we have to check the maximum value. For that we need to differentiate this function twice to get that S double dash of X. If it is less than 0, then it will gives you a maximum value. If it is greater than 0, then it will gives you a minimum value, right? So we will differentiate this and we will find the critical point. First I will differentiate this function. Differentiate with respect to X. So derivative of this will be S dash of X is equal to constant as it is, that is 2 pi H divided by R into derivative of X into R. R is constant as it is. My derivative of X will be 1. So we are differentiating with respect to X. We have considered this as S of X, okay, minus derivative of X square will be 2X. Now to find the critical point, we'll equate this one to 0. So here I write, so this is now S dash of X is equal to 0. So I can write 2 pi H divided by R into R minus 2X will be equal to 0. By equating this to 0, because this is a constant, we can write R minus 2X is equal to 0. So by this we can write 2X is equal to R and the value of X is equal to R by 2. Is it clear? The value of X will be equal to R by 2. We got X as R by 2. Now to check whether it is a maximum or the minimum value, we need to differentiate the function again. So we will differentiate this one. S double dash of X is equal to 2 pi H, this one. See, this is the S dash of X, or here you can see this is S dash of X. We have to differentiate. So the constant as it is, that will be 2 pi H divided by R and remaining terms derivative of r will be 0 minus derivative of x will be 2. So by this we got this as minus 2 into 2 will be minus 4 pi h divided by r. Here you can observe this one, s double dash of x will be less than 0, right? S double dash of x is less than 0 because this is positive and pi is also positive, 4 is positive. It is multiplied with a negative sign. Obviously s double dash of x will be less than 0, right? S double dash of x is less than 0. So we can say that if you substitute the value of x as r by 2. So this is now s double dash of x is now r by 2 is less than 0. So we got this as less than 0. So by this we can say that r by 2 is the maximum value. So we proved that the radius of a cylinder is half of the radius of a cone. Is it clear? So actually this type of problems are not important, but go through it once. Now see this problem. You have to find the local maxima and local minima. This is in the exercise 6.5 third main. I'll solve one problem and remaining problem you have to solve. Okay. Simple it is. To find the local maxima or minima, what we have to do? First step is h of x will be or f of x will be given to you. You have to differentiate that function, right? That will give you the f dash of x. After the f dash of x, you have to equate that one to 0. By equating this one, we will get the critical point, right? Some values will get, that is called the critical point. Then you need to differentiate the function further, that is f double dash of x, right? After that, you have to substitute the values of x here. Whatever the value we got here, you have to substitute that value. If it is that value is less than 0, negative, then it is called the point of local maxima. If it is greater than 0, I mean if it is positive, then it is called the point of local minimum. And then those values you have to substitute in the function f of x, that is called the local maximum value and the local minimum value. Remember this type of problems are important, okay? Now we will start with this one. H of x is given. Differentiate h dash of x is equal to derivative of sin x will be cos x and derivative of cos x is minus sin x. Next step, second step is you have to equate that to 0. That will be h dash of x is equal to 0. That implies cos x minus sin x will be equal to 0. We can get this as cos x is equal to sin x. When it is possible, the value of x is between 0 to pi by 2 and cos x is equal to sin x. Possible value is x is equal to pi by 4, right? Cos pi by 4 is also 1 by root 2 and sin pi by 4 is also 1 by root 2. So this is called the critical point, right? Now to check whether it has a local maxima or local minima point of, so you have to differentiate this function again. We got h dash of x, will differentiate this. H double dash of x is equal to derivative of cos x will be minus sin x minus derivative of sin x is cos x, right? So I can write this one as minus of sin x plus cos x. Now we need to substitute the critical point and you have to check whether it is greater than 0 or less than 0. H double dash of x is now, will substitute it as pi by 4. So this is now minus of sin pi by 4 is 1 by root 2, right? Directly I will write here. Cos pi by 4 is also 1 by root 2. So this one I can write minus 2 by 1 plus 1 will be 2 by root 2. So this is equal to minus root 2. Is it clear? 2 can written as root 2 into root 2. So 2 and 2 will get cancelled, minus root 2. So we got h double dash of x is less than 0, right? So h double dash of x is negative. So h double dash of x is less than 0. So x value, at the value of x is equal to pi by 4, the function, right, the value of x is equal to pi by 4, is called point of local maxima or local minima. If it is less than 0, then it will be a point of local maxima. Point of local maxima. Is it clear? At x is equal to pi by 5. Since at x is equal to pi by 4, h double dash of x is less than 0. So the value x is equal to pi by 4 is called the point of local maximum. Now we'll find the local maximum value. To find local maximum value, we have to substitute in the given equation, that will be h of pi by 4. Remember this? Okay, we need to substitute not in the h dash or h double dash, we need to substitute in the given original equation, that is h of pi by 4 will be equal to sin pi by 4 plus cos pi by 4, right? Sin pi by 4 is 1 by root 2 plus cos pi by 4 is also 1 by root 2. So 1 plus 1 will be 2 by root 2. I can write this as root 2. Is it clear? So this is called the local maximum value. Is it clear? X is equal to pi by 4 is called the point of local maxima, and this value root 2 is called the local maximum value. So it attains the local maximum value at the point x is equal to pi by 4. Similarly, you solve the remaining problems. Okay. Actually, this is not important. Just we'll see it once. Okay. Prove that the following function do not have a maxima or minimum. Okay. Or local maxima or local minimum. To find this one, what you have to do? You have to differentiate, right? If I differentiate this will be f dash of x will be equal to e to the power x. Next step, what I have to do? I have to equate this one to 0 to find the critical point. So if I equate f dash of x is equal to 0, that means e to the power x will be equal to 0. This is not possible, right? E to the power x can never occur a value of this is equal to 0. There is no possible values of x, right, to get this as 0. So it does not contain any maxima or any minimum. Is it clear? So simple it is. There is no maxima and there is no minima. If you consider this equation, if I differentiate this, g dash of x will be equal to derivative of log x is 1 by x. Now I have to equate g dash of x should be equal to 0. Can we find any such values for x? See, if it is x is equal to 0, then it is not defined, right? If I consider the positive value, then g dash of x will be greater than 0. If I consider the negative value, then it will be less than 0. But we cannot find any value such as g dash of x is equal to 0. So this function do not have any maxima or minimum. Is it clear? See students, this is the last concept of this chapter, finding the maximum and minimum values in a closed interval. Till now the boundary was not given. Here one closed interval will be given to you. There you have to find the maximum value and minimum value, and that maximum value is called the absolute maximum value and minimum value is called the absolute minimum value. And one more thing, from this concept you can expect, either 2 mark or 3 mark one question, or they may not ask any question. That depends. Okay, the important thing is just finding the local maxima, local minima, or this one absolute maxima and absolute minima. And in the previous session we have solved one problem, that is finding the two numbers, their sum is minimum. That problem is important. Other than that, whatever the problem we have solved, those lengthy problems, those are not important. But we cannot say, if you look at into the previous year papers, that was not appeared. But sometimes we cannot say, and we should be ready with everything. But that is left to you. You can make a choice between that. Just study the important also. It is also enough. Okay. Just we'll see this one, what it is. See, if I consider the function f of x is equal to x square. Okay. And this is defined in the closed interval 1 to 5. Okay. This is defined in the interval close 1 to 5. Now can we find the maximum value and minimum value? Obviously we can find, right? If I substitute x as 1, f of x will be 1. If I substitute x as 5, f of x will be 25. Is it clear? In between this, all the values will be between 1 to 25. Here the value 1 is called the absolute minimum value. Is it clear? Absolute minimum value, and value 25 is called the absolute maximum value. Absolute maximum value. See, here the function is f of x is equal to x square. So we can find easily, right? For some functions we cannot write like this, directly. So there is a method. What you have to do is, similar to the local maxima and local minima, you have to consider the function f of x first. Second step is, you have to differentiate this. Okay? So that will be f dash of x. Okay? After differentiating this one, you have to equate this to 0. so that we'll get the critical points. Is it clear? So that we'll get the critical points. Then next what you have to do is you have to substitute these critical values along with these end points. Whatever the interval will be given to those end points and these critical points you have to substitute in the given function f of x. Is it clear? You have to substitute in the given function f of x. Then you have to check where it has an absolute maximum value and where it has an absolute minimum value. For example, let me discuss one problem. F of x is equal to x square plus 3x. Okay, and the value of x is belongs to, let us consider 1 to 3. See, this is important. It is defined under the closed interval. X belongs to 1 to 3. Now first step I have to differentiate. So f dash of x will be equal, derivative of x square will be 2x plus derivative of 3x will be 3. Now next step is I have to equate to 0, right? F dash of x will be equal to 0, that is 2x plus 3 is equal to 0. By this x is equal to minus 3 by 2. So clear? This is called the critical point. Now x is equal to minus 3 by 2 is called the critical point. Now to find the absolute maximum or the absolute minimum, what you have to do is just you have to substitute this value in this equation. That is the one thing. You have to substitute x is equal to minus 3 by 2. That is the one value. Second value, you need to substitute the end points 1 and 2. You have to substitute x is equal to 1. Then you have to substitute x is equal to 3. Is it clear? First thing, you have to substitute the critical value. After that, you have to substitute the end points and you have to check where the function f of x has a maximum value and where it has a minimum value, and the maximum value is called the absolute maximum value and minimum value is called the absolute minimum value. Is it clear? Now let's solve some problems based on this. Find the absolute maximum and absolute minimum value of a given function in the interval, closed interval 1, 5. Simple. First what you have to do, differentiate it. It will be f dash of x. So derivative of x cube will be 3x square. So this will be now 6x square minus derivative of x square is 2x. So this will be minus 30x plus 36. This is the first. After that you have to equate this one to 0. So that is now f dash of x will be equal to 0. This I can write 6x square minus 30x plus 36 is equal to 0. I can take 6 common, right? So I can take 6 common and I can multiply here. So this will be now x square minus 5x plus 6 will be equal to 0. We got the quadratic equation. We will simplify this. X square minus 3x minus 2x plus 6 is equal to 0. I can take x common. This will be x minus 3 and here x minus 3 means this will be minus 2. So the values are x minus 3 into x minus 2 is equal to 0. So critical points are x is equal to 3 and 2. Now to check the absolute maximum or absolute minimum, we have to substitute x is equal to 3. Then you have to substitute x is equal to 2. Then we need to substitute x is equal to 1 and after that you have to substitute x is equal to 5 and you have to see where it has a maximum and where it has a minimum. We have substituted x as 3, 2, then end points 1 and 5. Here I have substituted. You have to substitute this one in the original equation. Okay, simplify this one. By substituting this we got the values here. Here you can observe this one. The value 56 is the maximum value, right? And the minimum value is 24. So clear? 56 is the maximum value and 24 is the minimum value. So we can say that 56 is the absolute maximum value. Okay, absolute maximum value of function f or interval is given 1 to 5 attains at the point. Which point it is? Maximum value attains at the point 5. Is it clear? Attains at the point x is equal to 5. So this is called the absolute maximum value. Absolute minimum value is 24 of a function f on the interval 1, 5 which attains at the point x is equal to 3. Finally you have tried this.